Okay, welcome back. One more video for Module 5. Going to do an example. So if I can get this to move forward. Last time I talked about geoprocessing workflow. Remember, there are chains of geoprocessing operations or a sequence of operations you can go through to get from your input data to the information that's going to answer the question of how or why or what's going on with my data. There are three spatial scopes. There's local, neighborhood, and global. Local concerns only one feature and its attributes or locations. Neighborhood concerns surrounding features, and global concerns all the features in your feature class. Went through a couple of quick examples using the United States and Utah and how those might be considered certain operations, local, network, and global. Okay, so this time I'm going to do another example, and what the question is that we're trying to answer by this example is how much area of the United States in the conterminous United States, or the lower 48, is more than 50 miles from a city with a population of at least 50,000. And this, although it probably isn't directly applicable to a real-world question that might be asked, there's been similar questions asked during the last year or so about the VA, the Department of Veterans Affairs, because what the VA has done is they have decided that if a vet lives more than 40 miles from a VA medical center, they're going to allow that vet to go to a local doctor as opposed to drive all the 40 miles to get to the VA center. So you can imagine that a question like this might be something that somebody at the Veterans Administration might be asking. Or maybe this is a social scientist who has a definition of urban and rural, so that anything within 50 miles of a city that has 50,000 people is considered urban, and anything that's not in that area is considered rural. So you can imagine where questions like this might be asked, and it might be your job to take the data that's available and come up with an answer to the question. So if I skip to the end of this question, this is what it'll end up looking like. And the answer is basically 64%, which to me was a surprisingly high number, of the contiguous United States is more than 50 miles from a city with a population of at least 50,000. So how do we get from our input data to this final product? And that's what we're going to use a geoprocessing workflow to do. Okay, so what's our input data going to be? In this example, we're going to consider that the input data consists of a feature class, a vector feature class, a polygon feature class of all of the 50 states. Okay, you can get this thing at the census website. And we have another vector feature class. This one's going to be points of all the populated places in the United States. Okay, and this isn't just large places, this is populated places, and so there is an attribute field or column in this table that has population. So we're going to be able to figure out which ones are large and which ones are small. So that's the data that we're going to start with. Now we need to answer this question. So in order to do that, we got to go through a series of steps. We'll call that a geoprocessing workflow. We'll apply some geoprocessing operations to the data and get to the answer out the other end. Okay, one of the first things that you might think about is those data sets that we have are for all 50 states, and the question's asking for the lower 48. So how are we going to restrict this to just the lower 48? Probably the easiest way to do this is to just use the selection tool to draw a rectangle or a shape around the lower 48 and just select those states and not worry about Alaska and Hawaii, and even Puerto Rico might be in this one. And once you've selected those, there's a function in ArcMap that you can use to create a new feature class from the selection. So we can be working with a new feature class that's only the contiguous or conterminous lower 48 states. Okay? So that might be our first step. Okay, now the next step is, well, we don't really want individual states. We're talking about the United States. Let's call it CONUS. It should be just one thing, not 48 separate things. It's going to make it a lot easier to do the analysis if we have one thing instead of 48. So how do we get rid of all of those state boundaries and just get one lower 48 polygon? You think about that, you say, how do I get rid of boundaries? From one of the early videos you might remember that when you do a buffer you can do dissolving. Well, you don't have to use a buffer to do dissolving. You can just do dissolving on a feature class and dissolve those common boundaries. So there's a dissolve tool that will run, and that will remove the state boundaries and leave us with one single polygon that is the conus polygon. Okay, so that sets us up to do the conus part of the operation. Now let's move over to the population. Okay, populated places has a whole bunch of places that have a varying amount of population, but we're only interested in population of at least 50,000. How are we going to select only those cities that have a population of at least 50,000? Well, when you think about that, the population is an attribute in the populated places feature class table, so we should be able to do a select by attributes to select only those things that are greater than or equal to 50,000. Okay, so that might be the next step. Once we have that selection, we can make a new feature class out of that selection, or we can just work with the selected layer as it is in ArcMap. Okay, so now the first part of that question says more than 50 miles. Okay, when you see a sentence that says within or more than and it has a distance, you should think about the concept of buffering. Okay, so in this case we want to get everything that's more than 50 miles from a city that has 50,000 people. Okay, if we make a buffer that's 50 miles around all of those cities that we selected in step 3, then we're going to get a bunch of circles around each one of those cities that represents everything close to the cities. So if we do a buffer, that'll give us everything close to the cities. And then what we need to do is somehow take that piece of conus and take it out of conus. And so that's going to be an erase type procedure. So imagine we make a buffer around the cities, a bunch of circles, and then we erase all of those circles from conus. What's left is going to be the stuff that's more than 50 miles outside. So more than is usually an erase operation. Within is a buffer operation and a clipping operation. Okay? So what are we going to do? We're going to buffer the cities from step 3 to 50 miles. Okay? And in this case, we're probably going to still have cities that are in Hawaii and Alaska that we need to deal with. So what we want to do is clip those selected cities to conus. So we're only going to have the buffer for those selected cities. Okay, we're going to take the conus polygon, drop it over the top of the buffer, and clip only those cities that are inside of the conus polygon out, not worry about the Hawaiian ones anymore, or the Alaskan ones. Okay, so once we've got these buffered cities that are clipped to conus, we can erase the buffered cities from conus. What's left is the stuff that's more than 50 miles from cities. Okay, if we want to keep the information and use it in the future, we probably want to add fields to our feature class. So we'll have fields that we can add for areas, but basically what we want to do is just calculate the area of our single conus polygon, calculate the area of the thing that we got in step 6, the conus minus the clipped buffer, and that's going to allow us to calculate a percentage by taking the conus area minus that buffered area and divide it by the conus area. Okay, we're going to come up with 64%. So you can see that this is a kind of long process. It's a geoprocessing operation. Think of it in the terms of language as a paragraph maybe, or a couple of paragraphs to get from our question to our answer. So we use these geoprocessing operations, we chain them together in ways that are going to make sense to get to the answer that we need. And there's not just one way of doing a lot of these things. There's multiple ways of doing it. Everybody has their own preferred ways. Sometimes the computer will run better one way from another, but as long as you get to the right answer, you're going to be able to be doing the right thing. And so that's kind of the essence of this vector analysis. Okay, one of the things that ArcMap has is this thing called Model Builder, and Model Builder allows you to drag and drop these geoprocessing tools onto a workspace and connect them together and basically make a workflow out of that. And so this is an example that shows what Model Builder would do to do the things that I just described to you in the steps. And you can see that we have two input feature classes, states and populated places. We need to get to CONUS, so we have a tool that's going to let us select everything but Alaska and Hawaii. That lets us have CONUS states. And then we want to dissolve all the state boundaries so we get a single polygon. So this is one kind of leg of our geoprocessing operation. Take populated places. We select only the ones that are greater than or equal to 50,000. That's the big cities. Okay. Now what we're going to do, this is all the big cities in the United States. We want to clip them so that we're only going to get the big cities that are inside of CONUS. Then we put a buffer around that 50-mile buffer. We take our CONUS that we made, the single polygon. We've got the buffered big cities. We erase the big cities from CONUS, and that gives us our final result. So you can see that this workflow, geoprocessing workflow, is a chain of connected operations and data sets that lead us from the input data that we want to the final data set that's going to answer the question that we have. And that's what vector analysis is about. It's getting from the start data to the end information that answers a question that you have. Okay, this has been a pretty in-depth module. Module 5 is kind of the core of a lot of what people will do with vector data. And so kind of the difference between someone who can make a map and someone who can do an analysis is contained in this module. And we went through it all in theoretically 1 week. You may want to take some more time to do this module. I think that there are only 6 modules planned up till midterm, and there's probably going to be 7 weeks worth of work up till midterm. So there's a little slack in this module. If you need more time to do it, that's fine. Go through the videos again, maybe do the practice. I've also included a link to a Dropbox site that has a couple of practice questions and data that you can use to try for yourself to do some of these vector analyses. Okay, next week I'm going to spend a little bit of time talking about network analysis. This is something you use all the time when you go on Google Maps and try to get driving directions or things like that. And geocoding, which is actually putting locations to addresses. So that's what's coming up in Module 6. Thanks for watching.